Right, so in this podcast we're going to come to really the conclusion of atomic theory. We're going to end with the quantum mechanical model. And essentially the quantum mechanical model kind of still believes there are such things as orbits, but instead of calling them orbits, they become orbitals. And orbitals are better represented in 3 dimensions. So orbits, you just need 2 dimensions to have an orbit. Think of the Earth going around the Sun. It just is a circle. But orbitals involve three dimensions, so think of them as spherical, or there's both length, width, depth, and height to them. So, and really the orbitals tell us the probability of finding the electron. So again, the probability of finding an electron. And orbitals basically constitute where the electron is most likely to be. So probability of finding electrons. And the further you get from the nucleus, the less likely. The closer you are to the nucleus, the more likely. Because, again, nucleus is positive, electrons are negative. And you can kind of see, if you kind of Google anything about orbital shapes, it's basically an electron cloud. And it just shows you where the electron's most likely to be. Alright? So these letters, S, P, D, and F, basically correspond to smoking rooms, premium rooms, deluxe rooms, and fabulous rooms. And really, what we're going to look at is start at the energy level. Alright? So the smoking room started on energy level 1, or on the first floor. Premium rooms don't start until the second floor. Deluxe don't start until floor 3, and fabulous begin on floor 4. So you've kind of seen that from the Alpha Hotel. Number of shapes. Number of shapes. S's have 1 type of shape. Alright? And notice how many S smoking rooms are on each floor. Only 1 of them. How many premium rooms do we have? We have 3 rooms per floor. Alright? So there's really 3 shapes for premium rooms. D's have 5. F's have 7. The maximum number of electrons per energy level per shape, or per type of orbital. So because S's have 1 shape on each room, they really have 1 room. And how many people can sleep in a room? 2. So the maximum number of electrons on an energy level in the S orbitals is 2, where P's can have a maximum of 6, D's can have a maximum of 10, and then F's can have a maximum of 14. Alright, so the next thing we're talking about is their shape in 3 dimensions. And S's, we're going to think of them as being sphere. So S starts with sphere, or sphere starts with S. So that's the easiest way to remember it. P's typically have some kind of peanut shape. D's have kind of a double peanut or a donut shape. Or donut. And then F's just have these crazy, really just funky shapes that you don't need to know about. But those are the shapes in 3 dimensions that these specific orbitals have. Alright, so here are just some representations of what the electron cloud actually looks like. There's this, what's called the wave equation, which was really come up with by Schrodinger, and it predicts, it's a mathematical equation which is extremely difficult, and I'm not going to try to show it on the board at all. But these are the shapes that are predicted by the wave equation. So here is what a 1s looks like. Notice it's just a sphere. 2s is just like a sphere as well. It's a little bit larger in diameter. As we go further and further from the ground level, if you're thinking of Alpha Hotel, we're getting further and further from ground. Our atoms get bigger and bigger and bigger. Alright? So the P's, here's what they look like peanut-wise. Is they kind of have a shape that's kind of 2 lobes, kind of above and below. And again, this is the probability of where you find the atom. So again, above, below, but kind of right there next to it doesn't. The wave equation doesn't suggest that the atom is there. 3s and 3b are just going to be bigger. Where the D's, here's our double peanuts and a donut. So notice instead of just having 1 peanut, we have kind of 2 peanuts, kind of 90 degrees from each other. And then we have this donut thing, which is kind of weird. And then again, when we get to F's, I say they're funky shapes. there is all 7 of them, and just crazy weird stuff. Alright? G's can also be predicted, so when we get to the 5th energy level, we can predict G's. There would be 9 of them. Here's what they look like. But again, that's just a way to give you kind of an idea of what shapes look like based on this, what's called the wave equation, which was generated by Erwin Schrödinger. And I'll get back to the lecture. The S, P, D, and F don't correspond to these shapes, but they actually correspond back to the emission spectra. And those really sharp defined lines is what S stands for. P stands for principal, and then the lines that are more diffuse or aren't quite as sharp, D is diffuse, and then F is fundamental. What principal and fundamental, what those mean, I'm not exactly sure, but sharp obviously comes across as how defined something is, and then diffuse would be kind of not near as defined, but kind of grainy on the edges. So again, these designations correspond right back to the emission spectra where Bohr got his model. Okay? So the last thing we're going to do on this one is the electron configurations then are ways of designating what electrons a specific atom has. So if we take magnesium, for example, and if we look on the periodic table, we find that magnesium has an atomic number of 12. So it has 12 protons, which also means it has 12 electrons. So think of electrons going to the Alpha Hotel, but we're not going to do it like that. We're going to do kind of some shorthand. So we're going to start with the first floor, smoking. And how many people can we put in that room, or how many electrons we can put? 2. Okay, so we've taken care of 2 of our 12 guests. Next, we're going to fill up the second floor, smoking. And how many guests can go in the S rooms? Again, 2. So we've filled 4 of our 12 guests. We found rooms for them. Next, we're going to have second floor premium. In the premium rooms, there's 3 of them, which can hold 6 electrons. So now, if we add up 2 plus 2 plus 6 is 10, so we've found rooms for 10 of our 12 guests. So now we're going to jump up to the third floor, smoking. Smoking room can hold 2 guests. And this right here is known as the electron configuration for magnesium. 1s2, 2s2, 2p6, 3s2. If we did something for oxygen, it's going to be a little bit shorter, because oxygen has an atomic number of 8. So it has 8 electrons. And this is something like this, 1s2. Filled up this first floor, so we're going to go to the second floor. First room we fill is smoking. 2 people can go in that room. And then we have second floor premium. And notice here, we're not going to fill up the orbital. We've already assigned 4 guests, we have 8. So we only have 4 left to put into rooms, or electrons to put into orbitals. So oxygen's electron configuration is 1s2, 2s2, 2p4. Next, we're going to do one a little bit higher, just to kind of see how the threes work. We're going to choose vanadium, which has an atomic number of 23, or 23 electrons as well, if we're talking about an atom. So again, our first 2, we're going to go in the first floor smoking, and then second floor smoking, and then second floor premium, which can hold 6. And we're going to jump up to third floor smoking, just like magnesium. Then after third floor smoking, we have third premium, which can hold 6 people. And then we can go to fourth floor smoking. And if we add up right now, we have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus another 2 is 20. So we have 3 more guests to assign. But instead of going to 4 premium, we now fill up the third deluxe. Now we're going to fill this with 3 people. So vanadium's is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 3. And that is the way electron configurations work.